It's just whatever it is, you buy out the business.
Not the whole business?
Yeah.
And I want to say they, oops, here we go.
How do they do that? Who cares?
I want to say they,
It makes a lot of money.
and then they closed out the shop in like Mount Pleasant, but, or something in Mount Pleasant. There was something happened in Mount Pleasant.
Because my dad still delivers there.
Oh, he still delivers it? Or is it just a printing place and not a shop? It's probably maybe just that.
I think it's just a printing.
I think they shut down the store, but
Okay.
they still had our
Because I know
store.
like my dad is like
Oh.
delivers there, because when like the basketball thing was going on, he bought shirts. And he was gonna be like, okay, like I'll just like, the lady's gonna like hold him there for me, so I'll just pick him up while I'm working. And then she didn't, so I had to go pick him up.
Oh, so maybe it's just the place where they do the shirts.
You know what that photo Dawson reminds me of?
Hmm.
That one guy from Sonic the Hedgehog, the bald guy with big goggles. And like
Dr. Eggman?
Yeah.
Okay, I don't know who that is, but we'll look it up later.
Dr. Eggman.
No, I don't know any of that stuff. Okay, next stuff we're gonna look at, trig identities, and like I said up there, it says it's kind of like solving a puzzle. And then the next chapter, okay, the next chapter that we do, it does get into vectors, but it also does, like, because we didn't talk about really the law of sines and law of cosines if you don't have a right triangle stuff. So that's still trig stuff, but I know it does get into vector stuff. Because like I said, we only have 3 chapters and then we have a final. So, okay, so trig identities. Now, these I gave you the notes here, so you have this down. So the first thing I kind of have in here, even though we've already talked about it, we've already used all this stuff, was just SOHCAHTOA, sine, cosine, tangent with opposite, hypotenuse, and all that good stuff. Like, you know, you label them O, A, and H, and you have those. So we have done stuff with this. Then you had your reciprocal friends, cosecant, secant, and cotangent. So if sine was hypotenuse or sine was opposite over hypotenuse, then cosecant was hypotenuse over opposite. So you just flipped it over literally. Okay, so we have talked about these things because you guys did make triangles and then find the 6. So I can kind of go through that a little faster here. All right. Trying to think of what we're doing today first. But so these, another way to look at them. So you're used to just flipping them over, but sine is 1 over cosecant. So that's why on here it tells you which ones go with which ones, which one is the reciprocal of. Let's see, there's that one. Okay. If you go back to the quotient identities here, when we were doing the snowman, we kind of came out with this. I know it's not up here, but I'm just gonna do it. Oh, my cats are right there. Okay, so if you kind of take it back to your snowman, and like this was 1, let's say this was 1/2, and this is square root 3 over 2, and then this point right here was this. I'm just pulling off one of them. Something like that. And then later on we went and put tan in there. Well, tan was just opposite over adjacent, which is just sine over cosine. So then we found tan, we did this. And then you did your copy dot flip or whatever you did, and we simplified that. But with this on our unit circle, tan was just this over this, which is, remember, these were written as cosine, sine. So that was sine, this is 30. So if you did sine 30, it was 0.5. If you do cosine of 30, you get 0.8-ish, blah, blah, blah. But if you do this over this, tan is just sine over cosine. So that means cotangent, it's a reciprocal, so it has to be cosine over sine. We're gonna use more of these tomorrow as opposed to today. Next one up there, I have Pythagorean identities. Sine squared plus cosine squared equals 1. Okay, so Pythagorean theorem, you know that. So if I just go back to this one, and if I do sine squared plus cosine squared, that's equal to 1. When I square that, I get what?
1.
When I square it,
1/4.
when I square it,
3/4. Oh my God, it's 1.
when I add it.
So it is 1, that's right.
So like any of those ones I had, it wouldn't matter which ones I'm just kind of pulled 30 out right here. So sine squared plus cosine squared equals 1. Now this one, the second one, if you divide the first one by sine squared, you get this one. So sine over sine would be 1. Cosine over sine is cotangent. 1 over sine squared is cosecant. Okay? And this one here, if you divide everything up here by cosine squared. Sine over cosine squared, tan. Cos over cos, 1. 1 over cos is secant. So just some substitution stuff in there. Like I said, we're not going to use all of these things today. We will use them more tomorrow. Even odd identities. So if I do sine of a negative angle, pull that negative sign out. Same thing on tan. You have tan of this negative angle. These just kind of even odd identities. Tan, it pulls it out. But cosine of a negative angle in there just gives you cosine. So you notice there's no negatives there. And like I said, I'm not going to use a lot of this today. I'll use a lot of this tomorrow when I do a bunch of examples. Okay, oops. Okay, so we're going to, no, only because when, I kind of should have left that out. When I do this with pre-calc, we haven't done tan yet. So you guys already have tan on yours. So that's why it's like, don't take it out. Don't do this. Yeah. Yours was fine. Just at that point, I have to go over tan because we don't use it until now. So that's why. But you guys used it before. Okay. So, what I'm going to have you do is we're going to look at this example. You already have it written down. So I need to, I need a piece of paper. Okay, I got to write this down. Okay, I'm gonna, it's not so much this one, but this one I do have on your paper, right? Is this on your notes?
Yeah.
Okay, let me get out of there. Okay, so it says find the exact value. Oh, so now this part right here will tell you where to draw your triangle. Because you're going to go back to making a triangle. And you're going to do a little a squared plus b squared with c squared to find your side. But this will kind of tell you where. Okay. This right here could also be written differently. Like it could say, I have this and it says, where tan is positive. Okay, well, this is positive and tan is positive in the first. So this could be written different to tell you where. This part right here is the how you're going to draw your little triangle here. And this right here is what I want. So you're going to give me the exact value of this. Okay, now before you draw any triangle and do anything, what do you notice about this? and this. Cosine and secant.
They're equal to
Now, what do you know about cosine and secant? It's the reciprocal of each other, right? Okay, so if cosine is 2/3, secant is what? 3/2. Okay, so for something like this one, I wouldn't necessarily draw out a triangle, do a squared plus b squared equals c squared, because then you're gonna be like, it was just 3/2. So for this one, before you make your triangle and do work, just check and see that those two things aren't reciprocals, because really it's just flip it over. Now, if you should forget, now don't write this down. If you should forget, okay, this is in the first quadrant. I do this. Cosine is this over this. And then when you take a squared plus b squared equals c squared, you go 9 minus 4, you get 5. And you go through all this work, and then you go, oh, I need this. Okay, that's hypotenuse over adjacent. And you're back to what you could have just flipped over. Don't go through all of this. Check that first. Okay, what's the next one I have up there? What is going? Okay, sorry. So the next.
Is that it?
Yeah. It's just tell me what the exact answer is. So when you look at this one.
So wait, what was the thing with like the 0 is greater than 0 but less than?
It was telling you to draw it in the first quadrant.
So you have to draw it too.
I wouldn't draw it if it's a reciprocal one. So like, look at this one. If I say cotangent is negative square root 5/2, and I want to know what tan is.
-2 square root pi 5
Over.
5.
Hey, there you go. Okay, so on that one, it's exactly what you just said. If I said this, and we said it was negative square root 5 over what? What was it? I don't have it,
-2 square root 5 over.
but the original one was negative.
-5/2.
Okay, so the original one was this one right here, and then I asked you about this. You don't need to draw me a triangle to figure it out, because these are reciprocals of each other. So yeah, just flip that over. But then you did that in your head pretty good there. I'm pretty proud of that one. So on this, you would just leave it like that. Now, the next problem is they're not reciprocals of each other. Okay, so here we go. Oh. Okay, I'm going to, I need to write this one down for me.
I'll sort it out.
If you want your snowman out, you can have it out. Okay, so just make sure before you go do a bunch of work, you look at them and see if they're reciprocals. This one is not. Okay, so I got this written down. All right, so this is where I'm gonna draw my triangle. Yeah. Where is between pi and 3π/2? Third, right? Okay, so if you kind of look, and you're just looking at your snowman there, you have a 270 and 360, and then you have 0, and you have your pi/2, you have your pi, you have your 3π/2, and then you have 2π. So that's what you have on your circle, your snowman right there. So if I said between pi and 3π/2, that's in between there. Okay, now the reason why I do that there is just, and you can draw your triangle however. I just get kids that mess up the signs with this. I don't draw anything to scale. I just draw it. Okay, so for this one, so that just tells me where I'm going to do this. Now, for this one here, where am I putting these numbers? Where am I putting the 1? Where am I putting the 5?
1 is the opposite, 5 is the opposite.
And then the 1 is going to be negative because you're going down. Because remember, this point right here is going to be this point, however much you went back and however much you went down. So the hypotenuse, just always leave it. Okay, so what's the other side? Huh?
It's a negative.
Well, it's going to be negative. So if I have 25 minus 1, it gives me what? 24. So square root of 24. Simplify square root 24. Cake it.
2 square root of 6.
Oh my gosh, you kids.
What?
Yeah, you're right.
Why did you say, oh my gosh, you kids?
I'm just proud. You're just knocking them out
Oh, I
there.
thought you were like, oh my gosh, like.
No, you didn't write anything down. You just did it. See? Kids are so smart. Okay.
You think too highly of us.
I do. All right. So for this one, 25 minus 1. And remember, when you square that, that's just going to be 1. So if I said cosine, you would say what?
Adjacent over negative 2 square root 6 over 5.
And you'd be done. Okay. Now, this here, you don't have to go draw it like this if you don't want to. Remember, it's part of that like bow tie I told you to do. That. You can kind of draw it however you want. I just don't want you to screw up a negative sign. So on this, if I put it where it should go, when I go back, I'm negative. When I go down, I'm negative. That's why I like to do this, because otherwise I get kids that screw up signs because they just draw a random triangle in there. Okay. What about that one?
Sec is cos.
Yep. Okay, see if you can set that one up. I need to look at it. You must have what?
7 squared, I put 35.
What? 7 squared 35? Oh my gosh. What's wrong with my children?
It's just
Okay, well, okay. All right. That's pretty good.
I can't do basics.
It's so gross.
That's so gross.
I actually just put co.
Cos is, like that.
Is it? No. Adjacent? No, because I have to do the exact same thing in my mind.
I didn't even do that. I hate
Yeah,
it so
I
much.
know. I know what she's doing too. You were trying to flip the 65
Yeah,
over and then to put it back, you're gonna have to redo it.
Yeah, there's no need to do that. God. Okay. I hate myself.
Oh, the thing is, I haven't even done it yet.
I always
So
do that.
this is the part here.
I do that. I didn't do the math for it.
Okay. I haven't even done. We're in the 4th, right?
No.
And like this, and you said 4 and 7 and minus and 49 and 16. What's 49 and 16? 65. 65 doesn't cake.
I didn't know that. I'm stuck in that.
I've done this problem before, but I know it just divide it by 5 and it's what, 13, something like that. What do you mean? Didn't you try to cake it? Okay, so, yeah, if you try to cake it, it'll divide. You know 5 will go in there, but it's not a pair. Okay, so secant is cosine reciprocal, right? So if cosine is A over H, this is H over A, correct? Yeah? Is that what you got?
Yeah.
Now, did you do 7 over square root 65 and then go from there
Yeah, I had to do that.
and try to flip it? See, I always look back at this because 7 over square root 65 and then don't try to simplify a thing.
And you have to write it down, so I'm like, okay, how's that step done? Yeah.
Sam, we're not gonna talk about it. We're just
It's
gonna
not gonna get harder, is it?
roll straight
It's
past
not
it.
gonna get harder, it's just gonna be more.
No.
It's not getting harder? This
Yeah.
is just the test,
Yeah.
right?
These notes are just because you hate trees. All these pieces of paper.
Like if we look.
Well, if you would rather me not print it off and write it all,
Oh, we haven't used.
there's always that.
We have to verify?
We will.
Oh my god. Are
We
we
will.
gonna do proofs?
Yeah.
Oh my god, thank you. My dad likes to antagonize me because he tells me about when he took calc in high school. Like one assignment took up a page front and back.
He's talking about, oops, where's it at?
He always says they're proofs.
Oh, yeah. Oh, where's it at?
And he likes to antagonize me. He's like, you're gonna do this one day.
Maybe it sounds like that.
Oh, where is it at?
Like,
No,
One
the
paper,
Tony,
right?
the Tony did it, and it was so bad.
this and this.
Yeah, it was one problem. And no surprise, it's math, I hate math. Yeah.
He's talking about mathematical induction, because that's what he said the other day. And I'm like, well, I don't get to that in a regular, I've never got to that in regular pre-calc. It's enough for me to get through part of that chapter and then call it a day. Okay, I'm gonna stop there. There won't be, well, there'd be 2 problems of the homework that would be this.